Cool. Thanks, Jez. It's wow, it's wonderful acoustics in here. Just testing them out before the talk. Great. So as Jez said, very briefly, until about a month ago, I was the CTO of a gaming company in San Francisco called Kixeye. It's about 550 people in San Francisco, and it builds real-time strategy games for web and the browser. And some of the things that I'll talk here are going to be about that experience. Before that, I was director of engineering at Google for Google App Engine, which is the world's largest platform as a service, and many of the lessons that we'll talk about here will be from Google. And then finally, earlier in my career, for about 6.5 years, I was chief engineer and distinguished architect at eBay. And I did a bunch of different things, but I mainly spent time working on multiple generations of eBay's search infrastructure. And again, we'll have some stories from there. So if the question is, how do I go fast? I often like to reverse things and ask, well, why do organizations go slow? Why aren't we always fast? And just sort of organizationally, I like to break it down into talking first about organizational culture, then about process, and finally about people. So first, let's talk a little bit about organizational culture. So the first thing that I think is important to instill into your culture is this idea of quality over quantity. And whether you're making a mobile app or a web experience or an internal application for people in your enterprise or a real-time strategy game, you want to think about the whole user or whole player experience. And we have this discipline in our industry, and it's a wonderful one, called user experience. And I assert that the experience of the user is more than the user experience discipline, if you see what I mean, right? It's an extremely important one, right? But it's beyond just the user experience. It's also the functionality, it's the performance, it's the bugs or the quality of the software. All of that stuff comes together in the experience of the user. And frankly, I mean, I'll say as a user myself, I don't care whether the unpleasantness that I'm having with an application is the cause of by quality or operations or development or specification or whatever. I want the experience to be good. And so what does that mean for us as developers or as people that are producing software? Well, I assert that actually less is more. And what I mean here is that I'd much rather have my team spend their effort solving 100% of one problem rather than 50% of two problems. And I'd not only prefer that sort of as a leader, but I'd also prefer that as a user. So again, imagine, the last time that you updated the OS on your phone or got a new app, you are on iOS 8 or whatever, and I doubt you said to yourself, wow, it's wonderful, there are 57 new features here. What you say to yourself is, wow, there is this 1 or 2 or 3 new features that are relevant to me, and wow, they really work wonderfully. So it's, again, from the user's perspective, it's not about the quantity of the output, it's about the quality of the output for the things that I care about. So how do we make that happen? Again, culture comes into play because it talks about a good culture has a good discipline around building quality. So I like to assert that quality and reliability are priority 0 features. We often think about, as we correctly should, the prioritization of features, say, in our backlog, and we might say priority 1, priority 2, priority 3, something like that. I assert that having the app be up or the system be up is a priority 0 feature. And again, back to the user, it's equally important to the user as the feature set. So if I want to play, one of Kixeye's games and the system is down, it doesn't matter to me how many wonderful features it has, right? It's unavailable. So how do we make this happen? Without talking about particular details, I personally assert and instill into my teams the discipline that developers are responsible for this full end-to-end experience, right? So it's obvious that developers ought to be responsible for features. I also claim, and there's good evidence to support it in the Agile community, that developers should be responsible for the quality of the software. They should be responsible for the performance of the software, the reliability of the software, and the manageability of the software, right? As a developer, all of this stuff is my responsibility. And I might have other people in the team that will help me with all these things, and we should all work together as a team. But ultimately, when I build a feature or I add something to the product, all of these things are my responsibility. So how do we do this? This won't be a new idea for people that come to a track like this, but again, I believe that developers should write tests and code together. Now, it's not particularly important to me whether the tests come first or last or in the middle or on the side, but ultimately, before I'm done with the code that I write for a feature or a system, it's important that there be tests. So that means in practice, continuous testing of obviously the quality of the features, also continuous testing of performance, of the load characteristics. And why do we do this? We know, but it's worth saying explicitly, that this gives us the confidence to make risky changes to the software, right? If we know that the tests have our back, we can be extremely confident, extremely courageous in making substantial changes, knowing that we're going to be able to catch any of the bugs or the issues or performance regressions that we might introduce. And of course, we catch bugs earlier and fail faster. And again, we all know it, but it's worth reminding ourselves that a bug that's caught by the developer, 5 minutes after he or she wrote it, is a lot easier and cheaper to fix. In fact, orders of magnitude easier and cheaper to fix than something that's caught by somebody later on, several hours later in a regression test, or on another, say, separate quality team, a day or two later. It's certainly a lot less expensive than being caught by the actual customer, right? Each one of those iterations is at least an order of magnitude, maybe two, in terms of cost and latency between introduction and fix. And so it behooves us all, just from efficiency, if nothing else, to try to catch all those issues as early as possible in the development cycle. So we often hear, and anybody who's been around for 25 years and has either gray hair or no hair like I do, has heard something like this, right? We don't have time to do it right. And I actually say wrong. I say we don't have time to do it twice, right? If we do something partially, if we do something knowing that it's actually not fully addressing the problem, we know that it has issues, we're going to have to come back around and do it again. So it behooves us to think very carefully up front about trying to do the best job we can from the beginning. And I'm not asserting we should try to build perfect software. There's no such thing. But we should do an 80-20 type of rule. We should spend that 20% of our effort building the 80% of the feature and do the best job that we can the first time around, rather than building something in where we know it's not gonna last. And I also assert that exactly in the case where you are constrained, in other words, exactly when you are constrained in time and resources, that's exactly the point where you don't have time to do it twice, where you should really spend the time to do it properly the first time. So the specific example I'm going to use here is the engineering discipline of the groups at Google. And this is a wonderful cultural aspect of working at Google. Very solid development practices. So there's no code that makes it into the main line of the source control that doesn't have at least one review by another Googler. It's part of the system. There's sort of no way you can get around it, which is good. And again, this is something that's part of the culture, that everything has automated tests, right? So some tests are better than others. But the discipline is that I'm not done until it's not only complete feature-wise, but that it's also well-tested. And Google, despite the extremely large amount of code it has essentially a single logical code repository. With a few exceptions, every piece of code that's written at Google can be looked at by any engineer within Google. And what that leads to, both of these together, is something that I'm making up this term, but it's something like an internal open source model. So a bunch of this code isn't available to people that don't work at Google, but the effect that it has is that all the code in all the repositories sort of act as an internal open source repository. And what does that mean in practice? So again, as I mentioned, I was director of engineering for Google App Engine. So App Engine is a platform as a service. There are about 3 million different applications worldwide that run on its infrastructure, including about 15,000 internal Google applications. So a bunch of Googlers are directly our customers, and they get to see our code. This is great. So there's a bug reporting system, of course, as at any company that does serious engineering. And so when our customers find issues with App Engine, they could file a bug, and that would be totally fine. But because they can see our code, because we have the code review process in place, and because they're engineers and all motivated, oftentimes, more often than you'd expect, instead of a bug report, what we'll get is, here's the bug that I found, here's the place in the code that was broken, here's the fix, here is the test that demonstrates the bug and verifies my fix. Awesome, right? That was so wonderful. And that happened, multiple times a week we'd get submissions from people that I'd never personally met. I mean, Google is a 50,000 person company, and frankly, often from places that I didn't even know Google had an office, right? A guy from really far away, completely opposite time zone from San Francisco would submit something and make typically a wonderful change to App Engine. And again, there's no danger there because it's like a pull request. This engineer would submit a potential change, and then we would code review it and decide whether we would accept it into the mainline. And oftentimes we would, because it was, again, we could look at the code, we could look at the tests. It was great. Excellent. So the next cultural thing that I want to talk about here is something that I call service teams. And Amazon and Google and Netflix all have all evolved independently around this similar model where teams that build a particular service or a particular product tend to be small and focused. And the discipline here is to make sure that a team is responsible for a single service or a set of related services, that service or services has a minimum sort of well-defined interface to the rest of the company or to the customers that they have. And even more importantly, a discipline around being able to rely in a formal way on other people's work within the company. And so the discipline that I use there is I talk about vendor-customer relationships. So and I'll give specific examples in a moment, but when I choose to build my service or product on top of another service, whether that service is provided internally by somebody else at my company or externally, we should have a kind of vendor-customer relationship there, right? In the same way as I would choose a third-party vendor and sort of evaluate them and be careful and be explicit about whose responsibility is what, we should have that same discipline when we operate even within our own companies. So clearly that contract, if you like, between the teams, no matter how formal you want to make this, has some idea of functionality, right? I mean, that's the easy part. Well, we can see the specification in the REST interface or whatever. So that sort of denominates or denotes the agreed upon sort of scope of responsibility. You pass me this, I'll give you that. But more importantly, particularly at Google scale, it's important to be explicit about service levels and about performance, right? So if you send me, if you call my service 10,000 times a second and it's 10 kilobytes per request, you can expect this particular latency distribution, right? You can expect to get an answer back in 20 milliseconds at the median and 40 milliseconds at the 90th percentile, et cetera. I mean, we can have this conversation, and you say what workload you'd like to send me, and I say how much, what sort of latency and performance and throughput characteristics you can expect. So again, I'll illustrate this with some examples from Google. So all engineering groups at Google call themselves services. And this is not just people who build API-only service. This is consumer-facing things as well. So people that are on the Gmail team say, oh, I work on the Gmail service. People who work on App Engine talk about, I work on the App Engine service. Those are consumer or non-Googler facing services. But there are tons and tons of internal services that support all the different products and services that Google offers externally. So one of them is Bigtable. There's a famous paper about that from 2006. Well worth reading. It inspired a lot of the NoSQL movement. And that's an internal service, again built by a relatively small team that has end-to-end responsibility and full autonomy for what they do. Again, these services are sort of self-sufficient and autonomous, right? So each of these individual groups sort of act as their own little bubble, and again with this nice, well-defined interface to the rest of the company. And then they are layered on top of one another. So in the example of, just to take one particular example, the hosted NoSQL service that App Engine offers to its customers, it's called Cloud Data Store. Not trying to sell you, but just as an example, is something that's built by a team of about 6 or 8 people. and that is layered on another service called Megastore. There's a paper about that. That team itself, end-to-end, is 6 people, which is in itself layered on a service called Bigtable, which is layered on a service called Colossus, which is layered on a service that does cluster management underneath. And the details aren't super important here, but what you can see are several things. You can see that there's this very explicit layering of services, and each of those services has its own sort of set of responsibilities and adds a new piece of functionality that's critical, layering up that stack. But also that all those services, because they can rely so fully on the underlying service to do its job, those particularly at the top layers of the stack, those teams can be extremely small, right? So the largest hosted NoSQL service in the world can be run by 6 or 8 people. Amazing. This works because of autonomy and accountability, right? So the autonomy angle is giving those teams within their little bubbles the freedom to choose the appropriate technologies, the appropriate working methodologies, and sort of the appropriate working environment for themselves. And you can do that because you've defined in a well-defined way the interface to the rest of the company. So again, like encapsulation of something in a programming language, you can't see inside, right? It kind of doesn't matter how it works inside as long as it works correctly from the perspective of the outside. So autonomy is one half of it, but the other half is accountability or responsibility, right? Giving teams the ability to make those choices also means they should have the corresponding responsibility, the corresponding accountability for the results of those choices, right? If the choices go well, great. If the choices go poorly, that's the team's responsibility. That's not something we can shift to someone else. So I like to hold my teams accountable for results rather than how they get there. So again, the little mantra that I say to myself is, I like to give a team a goal rather than a solution, and let the team own the way that they get to that goal, the best way to achieve that goal. So the example I'm going to give here is from the gaming company Kixeye. And we wanted to move toward we did and have moved toward a microservices architecture from something that was a bit more monolithic. Quite a bit more monolithic, actually. And after much thinking and working, we realized that, we want to build microservices, but it's actually hard. And and it took us longer than we expected. And we tried to figure out why. And one of the answers to the why was that what we really needed, we thought, was something that we ended up calling the chassis. And I hope people are familiar with this term. This is a picture of a chassis of a car. So a chassis is the underbody, the foundation of an automobile. And people may know that automobile companies tend to have a relatively small number of chassis, right? So in America, there might be a chassis for trucks, there might be a chassis for mid-sized cars or sedans, there might be another chassis for compact cars or small cars. So a relatively small number of chassis, but each of those chassis has a relatively larger number of models of different kinds of cars built on it, right? Many different kinds of trucks built on the same chassis. So that's the analogy we were going for here. There was a wonderful team of 3 engineers that volunteered for this job, and I was so happy they volunteered because I was going to ask them to do it anyway, because they were the perfect team to do it. But they volunteered, which is even better. So 3 excellent engineers, and they really didn't, minimum resources, minimum time, right? So it was basically 3 engineers, and they had about a month. And I suggested, not directed, but I suggested, hey, Netflix has done some really excellent open source work in this area for their microservices architecture. You really should check it out. And they said, oh, great, we didn't know about it. We'll let you know how it goes. These guys completely exceeded my expectations in every way. So they not only co-developed the chassis that I mentioned, the underbody of a car, monitoring hooks and client-side load balancing to downstream services and failure tolerance and all sorts of things that really every well-behaved service should have. They also developed a transport layer which supported sort of HTTP RESTful style, synchronous request response, but also a WebSockets bidirectional style, which is extremely important in a real-time game. They developed a service template to make it easy to build new services from within an IDE. They did a whole build pipeline. In this case, it was using Maven, that from that template would stamp out a service, and then again, leveraging a bunch of the wonderful Netflix tools, can deploy code in this red-black way up to Amazon Web Services and have a running service. So, and again, we ended up making very heavy use of the Netflix open source projects, which made it possible for this small team to do great work. And what we ended up with was we're now able to go in about 15 minutes from no code at all to a running service in AWS. Amazing. This was possible not because my guys did all the work, it's because they assembled together and built on top of the work of other excellent engineers, mostly at Netflix. And we thought that this was so helpful to us and completely transformed our ability to build new microservices that we actually have ended up open sourcing this ourselves. So you can see the link there to Kixeye's GitHub page where we have open sourced this, in some sense, conglomeration or aggregation of these different Netflix open source projects with a little bit of layering of our own. Great, great work. So the final set of sort of organizational culture things I'd like to talk about is around team-to-team interactions and collaboration. So it's obvious, and I hope we believe this by being in this track, but it's again worth making explicit that the best organizations act as one team across all the disciplines, right? So across the disciplines of engineering, product, operations, et cetera. And that gives us the ability to focus on solving problems rather than pointing fingers, right? And again, I'll give an example of Google. So Google has, to my mind, a sort of old-style organizational structure, but it actually works in a wonderful way. So at least when I was there, engineering was sort of one organization, product management tended to be another organization, operations was yet another organization, support was yet another organization, all rolling up to sort of parallel fancy VPs that none of us had ever met. But different reporting structures for the different disciplines. So you'd think that that would be a recipe for complete disaster. But in practice, what happened is everybody who was responsible for a particular product or a particular service, despite the organizational structure, all sat together and worked together as a virtual team with a single goal. So everybody, for example, that worked on Google App Engine all sat together in the same floor in San Francisco, the same floor in San Francisco and then correspondingly another floor in Sydney, Australia. And all the disciplines worked together, even though we had entirely different organizational structures. And those coworkers were not them, they were us. And the story that I like to tell that illustrates that is, this was in the Google San Francisco office, and the facilities people, the people that actually ran the building, came to us and asked the leadership about how we thought the App Engine organization was going to grow over time, and if we were going to need to move floors, and they wanted to do some space planning. And at the end of this conversation where they asked us, do you need to sit with this team? Do you need to sit with that team, et cetera, we'd figured out, we don't need to sit with support. They're loud. We don't need to sit with developer relations. They're always speaking at conferences. But we do need to sit with this team and this team and this team. And she asked, oh, well, I see these other people, these product folks that are in your cube area now. Do you need to sit with them? I said, well, they're us, yeah. And then she said, oh, well, I see these operations people, and they're in your cube area now as well. Do you need to sit with them? And I said, yeah, they're us. It never even occurred to me that they were not part of our organization. Never even occurred to me. So I like that. Great. So that's sort of organizational culture. Now I'd like to move on to talking a little bit about process. So a very important process in really any organization is instilling the discipline of constant learning. So we all know this, but again, it's worth being explicit that any process, any organization, any product can always be improved in some way. And of course, we're humans, so we're always going to make mistakes. And rather than beating ourselves up and blaming one another, let's use mistakes as a learning opportunity. So when something goes wrong, something always goes wrong, when we have an outage or something like that, some customer impacting failure, I like to ask, instead of asking, what did you do? I like to ask, what did we learn? And if we can take the emotion and personalization out of it, if we can take the blame out of it and replace it with a spirit of trying to improve the system, we're going to end up encouraging the teams to be much more iterative and to be able to move a lot faster. So the quotation that I like here is from a US president around the turn of the 20th century, Theodore Roosevelt. And he said that failure is not falling down, it's refusing to get back up. right? We know we're going to trip. We know we're going to fall. We know we're going to make mistakes. And the key thing is not to try to prevent ourselves from making mistakes. It's what we do after that. So again, I'll use the example from Google, and this is a discipline that isn't unique to Google. It's well sort of understood and practiced in the DevOps community, something called blame-free postmortems. So after every major incident, we have what's called a postmortem, where we document exactly what happened. We say to ourselves, because it's worth reminding ourselves, what went right, because often even if there was a disaster, lots of things actually did go right and did go as planned. Then we document what went wrong, and we have an open and honest discussion of all the people that were involved and affected about what contributed to the incident, what could we have done better. And what you find is if you can, again, take this emotionalism and blame out of it, that I found over and over again, to my wonderful, pleasant surprise, that engineers actually end up competing to take responsibility. So you'll have two teams, two different services that were sort of tangentially involved in the failure, and one service will say, okay, we did these things and we should have had a better run book and so on, and the other team says, are you kidding? We weren't even taking backups and our replication wasn't working and we'd had data corruption. I mean, it's this wonderful, if you make it about the improvement, the engineer, and you make it a safe environment, just our engineers, nobody's going to get fired or reprimanded. Everybody's very open about their own weaknesses. It's wonderful. And the other reaction that seems a little bit counterintuitive, but I probably think that it was familiar to all of you as it was to me, is a lot of times people's reaction will be this. I'm really unhappy that we had that outage, but finally we can fix that broken system that I've been complaining about for months, right? People had that experience. Finally, we can correctly prioritize this failure that I said was going to happen, I just didn't know when, right? Anyway, that's a wonderful example of this. So of course, we come out of this meeting with a set of action items, a set of things we're going to do. How are we going to change our process, our technology, our documentation? What could we have done to have automated some of these problems away? How could we have diagnosed it more quickly? How could we have restored service more quickly? Even if we didn't know what was wrong, how could we have leveraged replication or redundancy in some way to make it so the customer experienced less downtime? And then, of course, the key thing, once you say all these wonderful things and we add them to our backlog, is we actually should follow up, right? So weeks, months, whatever's appropriate for your iteration cycle, follow up and say, hey, how are we doing against these issues that we found? So a related idea here in terms of process is about iteration and experimentation. This is true really of any product, but it's particularly true of games, that it's important that we not assume that it's going to be perfect the first time we launch, right? Any online product, whether it's a game or a website or whatever, we have the opportunity to change it while, online, and we should take advantage of that. The thing I like to say is launch is only the first step, right? Particularly true for a game. We launch it, and we typically don't get everything right the first time. We assume that we're not going to get it perfect on the first time, but what we do is then iterate over and over and over again, making this improvement and that improvement, noticing customer feedback, making more improvements, and so on, and ultimately, instead of hoping for a success, planning for a success, engineering a success. And what I've seen time and time again is that many small experiments, many iterations that make pretty small incremental improvements end up summing over time to large wins, right? The analogy is kind of like evolution, right? There are typically not big changes, but there are very small changes that happen incrementally over time, which sum up to extreme changes in the overall animals as we go forward. So the example I'm going to use here is actually not from evolution, but it's from eBay. So again, I mentioned that I worked on the search engine there, and people are probably familiar with the general idea that one of the things that makes a search engine good, perhaps the thing that makes a search engine good, it's what's called the ranking function. It's the thing that decides what response to your query goes in the first position, what goes in the 10th position, the 100th, the 1000th, the 10,000th, etc. So Google has PageRank. That was, that revelation in 1998 was what allowed Google to sort of win the search engine wars, at least in the late 90s. And eBay had a similar idea. So For many years, eBay's ranking function was a hand-tuned ranking function by a very smart product manager, sort of hand-tuned these factors. And it was a very simple linear combination of, weighted combination of some factors. And to be fair to the product managers that contributed to this, they were pretty good. And it took us, as I'll show you, a year for us to beat it. But then we blew past it and have kept going since. Our goal, we knew that we had thousands of potential factors that we could use in the ranking. And our goal was to leverage those thousands of factors. And really the only way to do that is with machine learning. But we needed to figure out which factors actually mattered. So we embarked on this year-long process of experimentation. So we had a bunch of extremely talented data scientists that built a bunch of predictive models about how somebody who queried for, let's say, an iPhone 6, what was the likelihood that they would view a particular item? Once somebody viewed a particular item, what was the probability, the conditional probability that they would purchase that item, et cetera. And we did for a year, actually still ongoing, but particularly for that year, hundreds and hundreds of parallel A/B tests at any given moment. So we were testing slight variations in the factors, slight variations in the weights of the factors, and how we combine them, and so on. We made a full year of steady incremental improvements. And when I say incremental, I mean many improvements that we were extremely happy about would make a difference of 0.05% in the downstream metrics that we were tracking. So extremely small, but statistically significant improvements in the outcome. After a year of this, after just the first year of this, the output was an increase in 2% of the overall revenue of the eBay company. So at that time in 2010, 2011, eBay's global revenue was about $6 billion US, and so 2% of that was 120 million US dollars. Straight to the bottom line, with a relatively small team and a relatively focused set of effort on just improving the ranking function of search alone, changing nothing else about the site. And as an aside, at the same time as we did this effort, we also were doing a completely separate parallel effort on improving the speed of the search part of the site. So the insight here was, if it's a little bit faster to find things, that people are going to buy more. And that ended up contributing a totally independent and complementary additional 2%. So in aggregate, we got about $240, $250 million of revenue a year from these two parallel sets of small incremental experiments. The other thing I want to talk about process-wise is technical trade-offs. And this is just engineering that we all do. We're always, whether we're aware of it or not, we're always making trade-offs. And what I say is the important discipline is not to pretend that you're not making trade-offs, it's to be explicit that you're making trade-offs. So we're all extremely familiar with that dreaded triangle of, date and features and quality. So choose two, and we've already chosen the third. So for example, if you choose a particular date, you put a line in the sand or a stake in the ground. You choose a particular feature set, given a fixed set of resources, you've already chosen a particular quality. And whether that's the appropriate thing to do or not, be open and honest with yourself that that's what you're doing, right? Be open and honest and not pretend that we can be perfect on all three of those metrics. And the other discipline that's very related is when, not if, when we make decisions that accumulate technical debt, that accrue downstream things that we know we have to come around and fix, manage that. Be aware of it. Be open and explicit and honest with yourself that that's what we're doing. So when we accrue this technical debt, plan for how we're going to pay it off, right? And this is exactly analogous to how we all, I hope, run our personal lives, where if we take out a loan to buy a house or to buy a car, we should have some expectation about when and how we're going to pay off that loan. And of course, it's appropriate, just as it's appropriate for personal financial situations, it's equally important in engineering team situation to maintain a sustainable and well understood level of that debt. Great. So the last section here I'd like to talk about is about people. And the first thing I'd like to say is something that's easy to say and a little bit harder to do is hire and retain the very best people. And Google's not the only place to do this. Netflix feels the same way, and others. The discipline is around trying to hire A players, trying to hire the best people that we can. And we know this a bit intuitively, but there have been a bunch of studies since the 1960s and 1970s at Yale about measuring productivity, particularly in engineering disciplines. And what those studies have found consistently is that the difference between the best performers, no matter how we measure productivity, and the lowest performers is not a little bit. It's not like 2 times. It's 10 times. So the best performers, the most productive people tend to be 10x more productive than the least productive people. So it certainly behooves you to try to hire those 10x people. And even if you crassly only thought about money, you typically don't pay those 10x people 10 times the same amount. So you're actually winning on, if all you think about is money, you're winning on that score. But you also win on the coordination overhead. So people are probably familiar with Amdahl's law and laws about coordination. The more interactions that you have, the slower things will get. So you can imagine, if we really truly believe that, if we accept that some people are 10x more productive than others, then we can have a team of 3 people with extremely low coordination overhead, extremely fast velocity, that could do the same work as 30 people, right? Which is going to be individually much worse, much more expensive, and also much more hard to move forward, simply because coordinating 30 people is a lot harder than coordinating 3. The other angle here is a future angle. So if I have a team, or if you have a team of A players, those 3 A players, and you need to grow the team, those A players are going to want to hire other A players, right? This is like in professional sports, right? People want to play with the people who are at the best want to play with the best. And the sad truth, unfortunately, is where A players want to hire other A players, that's actually not true for B players. Typically, the experience is that B players often try to hire C players. And the intuition here is A players want to play with the best because they're confident in their own abilities, they're confident in their ability to improve over time, and they want to test themselves. B players are often less confident in their own abilities, less confident in their ability to improve, and so even B players would be a threat. So the trajectory tends to be B players will hire C players, and that's a sad truth, but it's something to be aware of. Great. So I'll give a particular example of the Google hiring process. So the goal of the Google hiring process is only to hire top talent, and you never make it perfectly, but that's the goal. That's why the system was designed the way it was. False negatives are okay. So when I say a false negative, I mean so Randy applies, they reject Randy, but ideally Randy would actually work well at Google. But they mistakenly reject Randy. This is okay. Google is very comfortable with rejecting me, fine. What they absolutely do not want to do is a false positive, where they mistakenly hire me, but I really shouldn't be there. Does it make sense? So as I describe this process, the goal here is to apply an extremely harsh filter so that only top people come out the other end. But it's okay if we lose some people along the way. That's the trade-off. Everything's a trade-off. So the process is a famously challenging set of interviews, particularly for engineering disciplines. Very detailed interviewer feedback, right? So for a 45-minute interview, an interviewer is probably going to prepare ahead of time, minimum a half an hour, and typically it takes 2 to 3 hours to write up all the feedback from the interactions that person had with over those 45 minutes. So it's a huge investment of people and effort into this hiring, into the interview process. Unique in my experience, hiring managers actually do not make decisions directly about whether people are hired at Google. Often they're actually not impartial about it. Hey, I've got this need I need to fill, and this guy's okay. Let's take that person. There's actually a separate hiring committee that is more objective and evaluates all the potential candidates that come through, in a particular area. And that hiring committee makes the first order choice: should this person be hired at Google or not? And then there's an entire second order set of choices about, okay, we decided that we'd like to have this person at Google. Now let's find a team that's the right fit. So there's typically a subsequent set of interviews, which are more like having coffee and informational style interviews that aren't about testing the candidate on their skills, but they're about, is it a right team fit? Is there an interest match between the team and the candidate? And the end result of this isn't, I don't try to say this is the perfect way of doing it. There are lots of different ways of achieving the goal, but what I'm trying to illustrate here is how much effort and thought has gone into this particular process, right? Whether you agree with the detail or not, a lot of thought and a lot of effort and a lot of metrics have gone into this. And the proof's in the pudding. Again, it's not the only way to do it, but the end result is that on average there is an extremely highly talented, extremely engaged set of employees at the company. So once you've hired them, treat them well. So in particular, this is a bit of a thing for me, is I strongly believe, and it's everybody's experience, I hope, that people aren't interchangeable, right? You know, your life partner isn't interchangeable with somebody else. Certainly in engineering, we all have different skills and interests and abilities. Even if we had exactly the same training, you know, we might have different interests in different areas. And the analogy that I like to use here is that we shouldn't try to create a factory where everybody's the same. We should try to create a symphony where everybody complements one another, right? So a symphony, like actually might be performed right here on this stage, you know, this weekend, for example, is a mixture of complementary skill sets, right? The symphony doesn't have all violins. They have violins and cellos, and they have horns and woodwinds and percussion, you know, all these different skill sets, each of which are playing well together, all together making wonderful, wonderful music. So that's the analogy that I like to use for teams. Not that I want everybody to be the same, but I want everybody to be excellent at what they do and complement one another in their skills and interests. People are your most valuable and most irreplaceable asset. Moore's law does not apply to people, right? The machines that we use every day are getting cheaper and cheaper and faster every year. Not true of the humans. So it's important that we treat those valuable humans with care and respect, right? And if the company values its people and demonstrates that value, people are going to turn around and provide good value for the company. So the counterexample that I'm going to use here is something that a development process that was at eBay when I first joined 10 years ago. And I want to be super explicit that eBay doesn't work like this today. It's actually a great place to work now, but it was not the best engineering organization in 2004. So circa 2004, 2006, eBay's development process went like this. Somebody would propose a project, so typically it'd be a product manager who had a great idea for a new feature or whatever. They'd have this idea, great. So they'd specify. It was a very waterfall process, which I'm not endorsing, but that's what it was. So here's the specification of what I want you to build. Then an engineer would be asked to estimate that work. So the engineer would say how many engineer weeks, how many train seats in eBay terminology would this cost, right? So I think this feature is going to be 10 engineer weeks worth of effort. Great. So far, so good. Then it starts to go off the rails. So that engineer that estimated it, who implicitly had in his or her head a design for what they were estimating, was not part of the implementation team. And correspondingly, the people that implemented that task weren't part of the estimation process or the design process or the sort of specification process. So the designer didn't implement, the implement didn't design. Yikes. Extremely dysfunctional results in the engineering culture, and eBay survived essentially despite this, not because of it. So first order problem is engineers were treated as interchangeable cogs, because the other thing that I didn't mention is that the engineers that were assigned to those implementation teams were pulled out of a random pool, just randomly. Okay, I'm going to take this engineer, and you're going to work for 4 weeks on this HTML work over here, and but I'm a server engineer. Yeah, so what? Crazy. So very little regard for skills, for interests, for experience of the engineers. Everybody was treated sort of equivalently. But the worst thing, the next worst thing is that for a particular task, even if everybody's behaving perfectly well and well-meaning, nobody had any pride of ownership in that thing, right? Because again, the people that are implementing it didn't design it, and didn't estimate it. Even worse, think about the effects that this has on the long-term code base, because nobody has long-term ownership of the particular area of code that they're working in right now, right? So again, even if everybody's behaving rationally and well, there's very little incentive, in fact, no incentive, to spend extra time on making sure that this is a maintainable thing, because you're never going to be back in this same part of code ever again. So really bad results overall. Please don't do this. But eBay's learned from this as well, and has a much more agile process, something that would be much more familiar, I hope, to people here. Great. So just to recap, again, I like, to answer the question how to go fast, I sort of like to think about why people might be slow. We talked a little bit about organizational culture, we talked a little bit about process, and then we talked a little bit about people. So now I'd like to give you an opportunity to ask some questions in the last few minutes. Thank you.
Okay, so if you want to ask questions, please chat them into the question thingy. The first question is, how do you coordinate priorities between customers for a service team and avoid politics?
Excellent. So the question, how do you coordinate between customers for a service team? There's no easy answer, but let's think about it a different way. Let's pretend that this service team doesn't work for us, but it's an external vendor. Same problem, right? So now how does a vendor prioritize? It's the same exact question. How does a vendor prioritize which customers are first? Well, typically a vendor is going to do a cost-benefit analysis for the prioritization. So maybe the biggest customer gets it first, or if I can make a simple change that can get us a new customer, maybe I'll do that. So it tends to be, what additional incremental benefit can I get for a particular resource input in the team? So I would apply that same discipline back inside. So the service team should talk with all those customers and also communicate back to them, hey, here's my current set of prioritizations, and if there's an issue with them, like, hey, team A and team B disagree about the prioritization, that's something that's very appropriate to send up the management chain, right? Whoever is the sort of decider where the organization comes together between the A and B ought to be able to helpfully make those trade-offs. If there is no such thing, or that takes too long, then I would make that decision based on shared understanding of the goals of the company, right? I mean, I hope we can all agree, even in a large company where nobody knows each other, I hope we can agree on, the goals of the company. Are we trying to hit revenue, or are we trying to increase market share, et cetera? And typically when people can have a conversation about those shared goals, typically people come up with pretty similar prioritizations. So I would encourage, again, that vendor-customer discipline, and then I'd also encourage a sort of collaborative discussion with those things. Because the benefit that you have when you're all one company is that there's no secrecy between the customers, right? I mean, that's typically not something that you have as an external vendor. You typically can't say too much, to customer A about what customer B is asking for. But that is a great advantage that we have inside a company.
Okay, one more question. Before we go to it, please remember to vote and give Randy your feedback on the session before you go. The last question is, how do you make code reviews at Google, and what do you think is the most efficient way to do code review?
Great. So how are code reviews done at Google? So Google has its own custom set of review tools, but it's very similar to several that you can leverage outside. So there are plenty of tools that are out in the open source and commercial worlds that you can use internally that would mirror Google's process. So the typical process is, I develop some code, and before it is checked into the trunk, it lives off on a little, branch as a change list, and when I check it in, before it goes into the trunk, I say this person should be a reviewer, and that person gets an email And then there's a web-based tool which allows them to very easily see the code changes that I've made, comment on them, and we can go back and forth on, I think you should put const here, or you're missing the point, that sort of thing. So we can go back and forth, and then we typically come to, an agreement on what should be done, and then ultimately it gets checked in. I hope that makes sense. Happy to answer more detailed questions offline if that wasn't sufficiently clear. What do I think the best way to do it is? I guess there are lots of different choices here. The thing I believe very strongly in is the review happens before it goes into the trunk or production, or before it has effect. I'd like ideally the review happens as part of the development process, rather than as a developer I think I'm done and then I have to come back around and do the review. And I hope the intuition makes sense there, because I want the developer, as a developer myself, I want to feel like the review is not something that's done after the fact when I'm done. It's something that's part of the conversation, part of the development process, in the same way as writing tests is. And typically at Google, when I was first there and building a service myself, I had lots of people that taught me a lot about how to build things at scale and how to build things particularly at Google. And we spent hours going back and forth. And this wasn't contentious in any way. I learned a lot. The person who was reviewing it actually learned a lot. So it actually was beneficial for both of us. So yeah, for sure, before it goes into trunk. And then tool-wise, I like something that allows us to annotate the code and have a conversation back and forth. And the particular tools I'm very agnostic about, but those two things I feel pretty strongly about. And happy to talk more about it in the break if you'd like.
And sorry, how long roughly does it take to go from submitting the code review request to getting the code review into trunk?
So that's a great question. How long does it take? It depends. As with any interesting question, it depends. So one stupid mistake that I did right here, at the time, 23 years of experience, I submitted a 1,000-line change list as my first one because I wanted to get it just right. Does that sound like a good idea? Do you think the person who was my selected code review was happy with that? He was very polite because he worked for me, but no, he was pretty unhappy. So what's the best way to break up a 1,000-line change list? It's 10 100-line change lists or 110-line change lists. And of course, the intuition and insight there is exactly project-wise, but writ small. It's incremental changes are very easy to review for correctness and for performance, etc. And they're much easier on the reviewer, and it leaves the cognitive load is much smaller for both the reviewer and the writer. And so the discipline that I had subsequently to my massive 1,000-line change list, which actually grew after the review to like 1,800 lines, too bad for the other guy, and I learned my lesson. So that took days back and forth, actually, but it was improving every time, and there was other work to do, so it wasn't like I was totally blocked. But what I learned from that was what I would have preached, but didn't follow, is do small change lists, small deltas, and review them as you go along. And that's much easier on everybody. Yeah.
Great. Thank you very much, Randy.
Thank you.